Okay, 7th graders, I need you to grab your book, a colored pen, and a calculator, and pause it. Okay, turn in your book to page 597. We're going to check the work that you did before spring break. Go to page 597. Go ahead and check number 7 and number 8. If you recall, I was asking you whenever you do these problems to have 3 steps. There should be 3 steps. You should have the formula written, you should have the numbers that you plugged in, and then you should have the answer. That's the least amount of information that you're supposed to have on your paper for every problem. What I'm trying to do is get you geared up to take geometry in a few years. Look at number 7. Remember, it says use pi as part of the answer. Sometimes they'll leave your answer in terms of pi. That means you don't have to take your calculator and type in 7 times pi, which would be about 7 times 3, which would be about 21-ish. You don't have to do that. You can leave your answer as 7 pi. Don't forget to label your answers. On number 8, why did I just do that? It's because I rounded. So this is an approximation, and it does say round to the nearest hundredth. I also noticed that I used the formula C equals pi d because they gave me the diameter. I could have used C equals 2 pi r, which would be kind of extra steps, but I would know that if the diameter was 20, the radius would be 10, and I could actually do it that way. So I wouldn't want to, but that's one way we could do it. Look at number 9. Check number 9. 24 pi, make sure that you labeled your answer miles. Remember, area is miles squared because that's what's inside. What we just found was the circumference. The circumference is all the way around the circle if I were to measure it. And then look at number 10. I did want to point out that the book is asking you to use 3.14 for pi, and I had told you to use the pi button on your calculator. If for some reason you didn't remember me saying that or read the directions, you would have gotten that. But this is what I wanted you to get. We're going to use the pi button. We're going to pretend like this is geometry in 9th or 10th grade. Okay, go to number 11. I wanted to finish number 12 with you. Go to number 11, check it. They gave you the circumference, so I plugged in the 27 right here for the C because we're trying to find the diameter. Make sure you round to the nearest 10th. All right, look at number 12. Back in the olden days, you used to use 22/7 a lot. They don't use that much anymore. They just use the pi button on their calculator, or 3.14. This book is just teaching you different things. What I'm probably suspecting they're wanting you to do is remember that if you wanted to solve for D, you multiply both sides by the reciprocal, because this is 22/7. Remember, you can reduce before you multiply, and then you get D by itself. That's kind of a review of your equations. And then you would just take your calculator and type that in. Okay, see if you get 3082.227 ... It says round to the nearest 10th, so that 2 stays a 2. So it would be about, let's see, this is in feet. It would be 3082.2 feet. Number 13. Oh, this is the best problem ever. This is a hard problem. So let's see who got it. It says the circumference of the inner circle is 44 feet. So that means the distance around this circle is 44 feet, all the way around. The distance between the inner circle and the outer circle is 3 feet, which they have in the picture right there. By how many feet is the circumference of the outer circle greater than the circumference of the inner circle? And they want us to use 22/7 for pi, round to the nearest hundredth of a foot. Okay, Here's the question. By how many feet is the circumference of the outer circle greater than the circumference of the inner circle? In your brain, you need to think of a plan. I need to know the circumference of the big circle minus the circumference of the little circle. So the circumference of the big circle, we have to find. The circumference of the little circle, they told, is 44 in the directions. We need to find the circumference of the big circle, the outer circle. Okay, in order to find the circumference of the outer circle, I'm going to go over here and do that. Circumference equals 2 pi r. Well, do I know the radius of the outer circle? All I know is from here to here is 3. The outer circle, this whole big circle right here, the radius is going to be this whole thing. We only know that from here to here is 3. We need to know what from here to here is, which means we need to find the radius of the inner circle. So let's find the radius of the inner circle. The inner circle, its circumference is 44. So I'm going to plug in 44 so that I can find the radius of the inner circle. Now they told us to use 22 over 7 for pi. So I'm going to change this to 22 over 7. That gives me 44 equals, y'all realize that this 2 is over 1. So 2 times 22 is 44 over 7r. All right, this is 44 over 7 times r. How do you undo multiplication, or how do you get rid of a fraction in front of a variable? Remember, you multiply by the reciprocal. And the reason why that works is you can reduce before you multiply. 1 times r times 1 is r. Over here, I can put the 44 over 1 and the 44s cancel, so your r is 7. So this radius in the picture that we just found for the inner circle is 7, which means the radius for the outer circle is 7 plus 3, which is 10. So now I need to find the circumference on the outer circle. So circumference equals 2 pi r. This is the outer circle. So that would be 2 times 22 over 7 times 10. I can do this several ways. You can just type that straight into your calculator. You can also put that over 1 and that over 1 and multiply it. Let's see. 2 times 22 is 44. 44 times 10 is 440 over 7. I could type that in. If I were you, I would just take your calculator and type all this in. Okay, that should give you 62.857 ... Leave that in your calculator because that's not our final answer. It's 62.857 ... Now just push minus 44 and you get 18.85714 ... Remember, I told you in real geometry, you will not round until your very final answer. Do not round inside the question. So that's why I had you leave the 62.857 in your calculator. Since it's on your screen, you just push minus 44, and your final answer is 18.86, and we're finding the circumference in feet. How'd you do? All right, that was an extremely hard problem. I can't wait to see you got that right. All right, open your book now to page 615, cross sections. I hope you had a lot of fun watching the videos that I sent you. Please make sure that you are doing every single thing I ask you to do. Since I can't be with you, the videos help in some things that I would demonstrate in class. Number 6, what are the dimensions of the cross section? Okay, this is just being sliced in half. So the dimensions of this rectangle, the up and down right here, which would be right here, would be 4 inches by, and then this right here would be the same as that, 2 inches. This is the formal way to write it, 4 inches by 2 inches. You can also write it as 4, remember this is the symbol for inches, times 2 inches. Okay, that means 4 by 2. All right, look at number 7. Okay, this is really hard to draw. I'm going to attempt it. Your vertical plane, it's going up and down, is perpendicular, so it meets at a T, to the base that intersects the 9. So it's basically going to intersect right there. It's perpendicular. That's supposed to be a right angle. And then it's going to go down the middle of that side and down the middle of that side. That's not a bad drawing. So the question is describe it. It is, and the best way, you might have just put a triangle. It's actually an isosceles triangle. And if you really describe it, the base would be what? Look at the base right here. Wouldn't the base be the same as this? It'd be 8 inches. And what's the height? The height would be 12 inches. That is an extremely specific description. Isosceles, remember, is isosceles triangle is a triangle that has 2 sides that are congruent like that. Okay, very cool. Next problem, look at number 8. All right, check your answer to number 8. It is a rectangle that is 2.5 inches by 3 inches. It says describe the vertical cross section. So it's going to cut it right here in half. Down here. So it's inside. That's a horrible picture. Maybe something like that. So it's 2.5 up, just like this is 2.5 up, and it's 3 across here, just like it's 3 across here. Okay, look at number 9. What is the cross section of the vertical cross section? So it's going up and down. What would the dimensions of that be? So this would be a rectangle. This right here would be the same as here. So 3 feet by, and this part of your rectangle would be the same as this. So it'd be by 9. Okay. What would be the dimensions of a horizontal cross section? Okay, if I drew a horizontal one, it's so hard to draw. I feel like this. That like this. So it would be 9 feet by, this, let's see. This would be 9, so that would be 9. And this one right here would be 5 because this is 5. So this is 5. So this is 5. All right. Then look at number 10. Okay, number 10 is a rectangle. Now, some of you probably just put rectangle. What I'd like you to do is put the dimensions. So go ahead and pause it and do that right now. Okay, the dimensions on this would be 6 right here, because this is 6, by, if this right here is the same as that, so it's by 11 feet, 6 by 11 feet. B, is it possible to have a horizontal cross section with different dimensions if you had a plane intersect the prism at another height? So what it's asking you is, if you had another plane that went up here instead of straight down the middle, would it have different dimensions? Or if there was one low down here, If there was a slice of paper that sliced it in a different horizontal place, would it have different dimensions? So no, of course no. No, the dimensions would be the same, no matter where the horizontal cross section is. And number 11, okay, I'm going to kind of attempt to draw a right rectangular pyramid. The reason why it says a right rectangular is that's just a pyramid that goes straight up. That means the height going down the center of the pyramid is perpendicular to the base. So if it was a pyramid that was kind of slanted, they have different names for that. A right rectangular pyramid, 12 by 6. So here's the base. And then the height is 14. So if that's 12, 14 would be about here. And then you connect all the sides. And if I want to make this really right, I will do this. So there's my version of a right rectangular pyramid. The height of a pyramid goes straight down the middle and is perpendicular right here to the base. So that would be 14. So this would be 12 by 6 by 14. Okay, so describe the cross section formed that intersects the faces above the base. If I have a cross section that just goes straight across, it's a horizontal plane. Right there. That's going to be like that. So it would be a rectangle, just like the base is a rectangle. But if you wanted to be a little more specific, you could say it's a rectangle with length and width less than 12 by 6. All right, guys. That was just like what we would do in class. Y'all have a great day.